So we want to evaluate the sine of I. And in order to do that, we're going to need to develop a form of the sine function which will take imaginary numbers. We've got a unit circle superimposed on a complex plane. So there's the real axis and there's the imaginary axis. This point is 1. This point is I. There's -1. And here's -I. All right. And now let's consider this point right here. And this is our angle theta. So we can represent this point in a couple of ways. One way is to call it the cosine of theta plus I times the sine of theta. And you know, when we do that, it's like we're considering this point here to represent a vector. And cosine theta is the horizontal component, and sine theta, or should I say I sine theta, is the vertical component. Now, there's another way I can write this, and this is using the polar form, which is e to the I of theta, and that's very concise. Now, I'm going to reflect this vector across the imaginary axis. So now we have a new point. And yes, this is theta here, but of course we're interested in this line that goes all the way around. So that's the angle. That angle is actually pi minus theta. So what do we have here? We've got e to the pi minus theta all times I. Okay. Now, we're going to simplify this, and we'll do the chicken scratches over here. So we can rewrite this as e to the I pi times e to the I theta negative. All right. Now, this is famously -1. So we can rewrite this whole thing much more simply as negative e to the negative I theta. All right. Now, what I wish to do is to add up these two vectors. Now, what will happen when we do that is the horizontal components are just going to cancel out. And effectively, what we're getting when we add that is going to be twice I sine theta. So these two vectors, we add them together. There's your parallelogram. And we're going to get a larger vector here, which if I try to draw it in, it ends up getting very messy. But that point here is twice I sine theta. So let's make a note of that here. We've got the sum of these two vectors is e to the, this one was e to the I theta, plus this one, so plus minus e to the negative I theta, and that equals 2 times I sine theta. Now we're just about there. Let's clear this so that we only have this last bit. Okay, so we were left with this expression, and it equals 2I sine theta, but we just want sine theta. So let's remove this and put it to the bottom of this expression on the left. And now, there we have it. We've got an expression for the sine of theta using these exponentials. Let's now just, if we want the sine of I, we're just going to plug I into this equation in the place of theta. So the sine of I equals e to the I times I minus e to the negative I times I all over 2 times I. Okay, and what does that equal to? That equals e to the negative 1 minus e to the negative 1, so e to the 1, all over 2 times I. And that's really it, but we can change its form, make it a little prettier. So we may prefer another form for this solution. We could pull out this denominator and write 1 over 2I all times. We'll make this 1 over e minus e. I think that's a little prettier. And again, if we don't like this I in the denominator, we can multiply by I over I, and then we'll end up with I over 2, and all that's going to be negative now, times 1 over e minus e. Okay, and that's the sine of I. Bob's your uncle.